Hi class, and welcome to another chapter. We're on chapter 7 now, which is titled Polynomial Functions. So in this video, what we're first going to do is we're just going to define a couple of the terminology aspects of this lesson before we get started. So for the very first thing, we're going to find what a polynomial function is. A polynomial function is a polynomial in only one variable, which means that it only contains, obviously, one variable. So if we take a look at this, f of x equals 5x to the fourth minus 3x squared plus 7. Okay, you only see one variable, and that variable is the x. You're never going to see something like this in this class, where it's f of x equals 5x to the fourth minus 3y squared plus 7. This is never ever going to happen because it has two different variables, x and y. So you're only going to see one and only one variable. Another thing that we have to define is the degree of the polynomial. The degree is the greatest exponent of the variable. So if we continue with this example, the greatest exponent that you see up here is 4. So the degree of this polynomial is the number 4. That's what the degree is. It is the greatest exponent. And then lastly, the leading coefficient is the coefficient of the term with the highest degree. Remember, the coefficient is the number that comes before the variable. So the coefficient, the number that comes before the term with the highest degree, the degree is 4. So what is our leading coefficient? Our leading coefficient is the number 5. 5 would be the correct answer for that one. It's the coefficient of the term with the highest degree. Now they might throw some trick questions at you if they were to say, Excel math being if they were to say f of x equals 7 minus 5x squared minus 3x to the fifth, what is your leading coefficient? Well, your leading coefficient is the number in front of the term with the highest degree. So your degree is 5, so what is your leading coefficient? Your leading coefficient is the negative 3 in this case. So just remember, go to the degree, the highest degree, and then it's the number right in front of that variable. That is the leading coefficient. So, kind of a summary of what we've been talking about ever since the very first chapter. Write an example of each of the following equations. A constant. A constant is a completely horizontal line. Okay, it is constantly 3, or it is constantly 5, or in our case, I want you to write this down in your notes, y equals 6. This is a constant function. There is no slope to this at 1, 2, 3, 4, 5, 6. We have a completely horizontal line. There's our constant function. Our linear function is our y equals mx plus b type lines. We're going to have, for an example, is y equals x plus 6. So this is where we're going to have a y-intercept of 6, and then it's going to have a slope of 1, rise of 1, and a run of 1. So our slope is going to look like this. So there's our line. Our next one is a quadratic. We just got done studying quadratics in chapter 6. Quadratics have y equals x squared plus x plus 6, for an example. These are always going to be parabolic in shape, so it might look something like this. Or if it was a negative x squared, if this was a negative, then it would obviously open down. Something like that. Now our last thing, which we haven't dealt with just yet, we're getting to it in this chapter, is our cubic functions. A cubic is a type of polynomial function, in which case your degree, the cube meaning raised to the third power, your degree is 3. Cubic functions oftentimes have this kind of a look, where they start in the negative, they have a hump here, and they go to positive. So this would be an example of a cubic function. And like I said, we're going to be diving much more into detail with these cubic functions as we go on into chapter 7. So now we're just going to practice labeling a few of the terms that we've been talking about. In the directions, it says find the degree and the leading coefficient for each polynomial function in one variable. So letter A, 7x to the fourth plus 5x squared plus x minus 9. The degree is that highest exponent. So in this case, it is the number 4. Our leading coefficient is the number right in front of that. That leading coefficient is the number 7. So for letter A, the degree is 4, the leading coefficient is 7. Letter B, 9z cubed minus 4z squared plus z. Even though our variable isn't x's, this is still a polynomial function because it still only has one variable, that variable in this case being z. Our degree is our highest exponent. That is the number 3. The leading coefficient is the number in front of it. That number is 9. Going on to the next one, 6a cubed minus 4a squared plus ab. If you notice this one, hopefully it looks kind of weird to you, and that is because it has a's and b's in it. We only have polynomials in one variable. So this one we cannot do. You can just put can't. Has two variables. So we don't say that this one has a leading coefficient, or we don't say this one has a degree because it has two variables. We don't do anything with this one. So for our last one, letter D, 9y minus 3y squared plus y to the 4th. Be very careful on this one. Our degree is our highest exponent. Which one is highest between 1, 2, and 4? Obviously 4 is the highest, so 4 is our degree. Most oftentimes it's written in descending order, but it doesn't have to be. So make sure you're aware that your degree isn't always the one that comes first. It is the highest exponent. And then the leading coefficient is the number in front of that. If there's nothing in front of that number y to the 4th, you just assume that it's a positive 1. So our leading coefficient is a positive 1. That's the terminology aspect of things in this chapter. Let me know if you have any questions on that. I will now record another video lesson talking about evaluating polynomial functions.